Hello, I'm Honggyu and I'm here with the theme of Predictive Intelligent Driver Model using deep learning based prediction of surrounding vehicle trajectory. Let me tell you the introduction of the research first. In autonomous driving cars, the control module should be the most relevant part of the passenger's safety and should be aimed at driving safely. In recent years, ADAS such as ACC, LCAS has been commercialized and used in various situations, but there are a lot of dangerous areas when following the vehicle ahead at high speed. To minimize and improve these risks, various ADAS studies using the deep learning are currently underway. And I will use cruise control with deep learning based trajectory prediction in this section. The following is the path prediction part of the study. As a data set for trajectory prediction model learning, an open source data set called HighD Dataset was used, and it was pre-processed according to its purpose and applied to the deep learning model. The model uses the LSTM encoder-decoder model, which has excellent performance in processing time series information and processing long sequence inputs. And the approximate model configuration used in the study is shown. Out data is the prediction of path for the next 5 seconds, and the video shown next to it is the actual prediction image. The following is the predictive intelligent driver model configuration. To explain simply through the configuration diagram, the values obtained from the sensor are applied to the learned deep learning model as shown in the figure below, and the predicted information is used in the P-IDM algorithm through the model. Using the minimum as the final input value by comparing the calculated target acceleration with other existing target acceleration is final proposed controller configuration. In this illustration, while the traditional IDM uses this information, but the P-IDM will use this prediction information. Therefore, the strategy is as follows. In the case of the simulation environment configuration, the vehicle simulator, deep learning model, and the longitudinal control module were interlocked, and two scenarios were used, cut in and cut out. This is video driving scene of cut-in scenario. This is the final driving graph, and cut-out scenario video. You can see that a normal vehicle reacts slightly faster than a transparent vehicle. And this is the final driving graph. So that's the final conclusion. Recognizing the limitation of the existing front vehicle follow-up controller, this paper presents two objectives and developed a new control algorithm model P-IDM. Driving performance was verified and evaluated by applying the proposed algorithm to the vehicle simulator in real time. And the research of the experiment showed that driving safety, traffic flow control, ride comfort, and driving fuel efficiency were all good. Therefore, the proposed algorithm is likely to enable forward-following cruise control with better performance than traditional IDM in high-speed driving environments and adjacent lanes vehicles situation. Thanks for watching.